All right, good morning, everybody. Today we're going to be doing the notes section 7.3. It's called, should be 7.1, but that's okay. What we're going to be doing today is we're going to be simplifying rational expressions. And if you look at your new word wall that you should have picked up, we should understand that a rational expression is basically anything that's a fraction. And then the idea is when we have two things that are multiplying, like they are here, A times C, B times C. And again, the B can't be a zero, the C can't be a zero because you can't divide by zero in math. Then the idea becomes all right, well, if they have something in common, then we should take it out. And so if they have something in common, we'll take it out. Just like the C was, they canceled. So I'm left with A over B. And so we divide out the common factor C. Now that's easier said than done, but this is why we've been working with factoring. Factoring is big for us in this class. And here it is again. So the idea is now you're going to use your word wall and you're going to try to factor and cancel. That's how we simplify our fractions, just like we saw on top here. So we're going to take a moment to factor the top here and we're going to factor the bottom. And we do it separately, of course. If I look at the top, there's no GCF. I can go right into my X factor, the diamond method, negative 12, negative 4. We ask ourselves what multiplies to give me a negative 12, but they combine to give me a negative 4 as a result. Well, for that value, we end up getting for a 12, let's see, we get a negative 6 and a positive 2. And because there's no a value, we don't have to reduce. So we're going to go right into our fraction here, x minus 6, x plus 2. And then we look at the bottom one. And for the bottom one, we say, hey, that's a difference of squares. Remember, those are the ones that we give a power of 2. We break it up first into powers of 2. For the x, we go with an x. For the 4, well, what gives me a 4? 2 times 2. So 2 squared. And according to the word wall, these are the ones where they look exactly the same. There's the x plus 2, except for the second one that has a minus sign in it. And so just like that, we have factored the top and we have separately factored the bottom. And when we look at it carefully now, we can say, hey, wait a minute. They both say x minus 2. And if they both say x minus 2, and remember, you can only cancel when things are multiplying, then we are able to cancel out the entire factor. So you can't like say, oh, look, they have x's. Let me cancel the x's. No, no, no. It's the entire factor or nothing. So what I'm left with here is my answer. I don't even need a parentheses because there's only one factor left, x minus 6 over x minus 2. And no, you can't divide these. No, you can't cancel these. You either cancel the whole thing or don't cancel anything. And just like that, here's my answer. Now, I will give you a heads up on big ideas. This is what you're going to be doing. But on big ideas, they're going to say, hey, there's an x that you canceled out. So just a heads up, if they do ask for it, see, this is what ended up getting canceled. And so according to big ideas, they're saying, hey, this is a letter or a number that you can't use. So all you have to do is basically say x plus 2 can't be 0, take away a 2. And so some of the questions on big ideas, you're going to have to type this in. This is the one value. By canceling out, if I were to graph this thing, it would show us a graph with a hole in it. There would be a little hole in it right at that value. But we'll talk more about that once I'm back in class. So here we go again. Again, the question or the issue today is we're going to factor and cancel. And then we're going to keep track of that cancellation that we got. Okay. So again, in big ideas, they might ask for that value. Look at letter B. We're going to try it again. Well, for this one, yes, I need to factor the top and I need to factor the bottom. So find any space. So we'll do this up here. So here comes the x factor for this one. X times or 1 times negative 3 is negative 3. The bottom is negative 2. Because this is a negative 3, then we say, all right, this is a positive 3 and a 1, or a negative 3 in this case, and a positive 1, because that's the only way to get a negative 2 as a result. So my factors become x minus 3 and x plus 1. So again, you're just factoring separately. That's why we've been practicing. It's finally led to this. And then here we can do another x factor. It doesn't have a GCF. That's why I'm going right into it. This is negative 6, negative 1. Well, once again, the only way to get a 6 is 3 times 2, and they'll subtract to give me a 1. We just have to make sure that 3 is the negative. And so we write it out. X minus 3, x plus 2. And if you notice right away, these two factors are exactly the same. So I can cancel the entire thing out, leaving me with an answer of x plus 1 over x plus 2. But like I said, on big ideas, it might say, hey, what's the x that you're not allowed to bring into this problem, right? Which one's the one that got canceled? So it might have an extra little box. Again, just a warning for big ideas. All you have to do is x minus 3 cannot be 0. So I add a 3. And so they're saying the x value that just doesn't work, got canceled out, would be the number 3. And so we would put that into the box. So again, just a warning on big ideas math, they're probably going to be asking for this. Okay. On paper, we're just looking for this part. Now, that's if we just have one fraction. But of course, if you look at the top, it does say we're going to be multiplying and dividing rational expressions, aka we're going to multiply and divide fractions. So we continue. Now, when you're multiplying rational expressions, it says we're going to let the A, B, C, and D this time represent or be expressions where B cannot be a 0 and D cannot be a 0. Remember, once again, that is following the one basic rule in math that says you can never divide by 0. Dividing by 0 is just impossible. And so one of the things that you have to remember from your back in elementary days, when you're working with fractions, we don't need a common denominator. We just multiply straight across. That's why A times C is just AC. B times D is BD. So we're going to make a little reminder to ourselves. No common denominator is needed. So what we're going to do is multiply across, not cross multiply, across the top with the top, the bottom with the bottom, just like that across. And the last thing we need to remember is we're going to factor and cancel because that's our goal here. Just like we did on top. If I want to simplify a fraction, I want to factor and cancel this out. So with that said, we're going to start off with an easier one where it's just variables. And yes, you have a couple like these in your homework as well. It says find the product. Now remember, product just means the answer to multiplication. So it does mean to multiply here. Some people tend to forget that. All right, but we're going to go straight across. That's it. So the top with the top. Now remember, the rule is numbers with numbers, letters with letters. So it says 5 times 6. Well, that's just 30. X squared times x to the 1. Remember, this is where we add our powers. Feel free to add that extra note if you need it. But x squared times x to the 1 is x to the 3rd. And yes, there's also a y involved in that process. So there's a y to the 3rd. No change in that power because there's no other y to work with. Now that's the top. Now we're going to look at the bottom. So when we're looking at the bottom here, again, we're going to multiply straight across. Keep track of all your numbers. Numbers first. 2 times 10, well, that's 20. The x, well, there is no other x, so we're going to write the x. And then it's a y squared and a y to the power of 1. Again, we add our powers. So y to the 3rd. So you see, you can make little notes there. You're adding powers, right, at this stage. But now when I'm over here, now it's time for us to simplify. Well, remember, this is just a fraction. And so when we're dividing, it says, what's 30 divided by 2? Well, we need to reduce that. So I'm going to divide these by 10 because 10 goes into both. So now my answer has a 3 over 2. Notice I stretched out the fraction. Just see there might be other stuff left over. Now let's talk about the x's. So you see, at this point, we were adding powers because we were multiplying. But now we're dividing. And when we're dividing, remember, this is, of course, when we subtract. That's not how you start the word subtraction. So this is how we subtract, or when we subtract our powers. So I have more x's at the top. So I'm going to go x 3 minus, remember there's technically an invisible 1. And notice I put the x on the top because that's where I had the most amount of x's. Now, when I look at the y, we should realize, wait a minute, I don't have more at the top or at the bottom. They're exactly the same. Well, when they're exactly the same, I'm just going to subtract my powers, so I can pretty much write it anywhere. Look at that, 3 minus 3, which means I'm really just going to cancel out that y. So my final answer officially is 3x squared over 2, because the 3 minus 3, again, that's really just me canceling it out because it's a perfect match. So we shouldn't even be writing that. But technically, right, if we were doing the subtraction of powers, that's what we would do. And there's my answer. But then, of course, they're going to get more complicated. I mean, look at letter B. That's probably as bad as it gets. When I'm looking at letter B, to finish this first part of the notes, we look at it and we go, all right, well, let's see. 3x minus 3x squared. Yes, I need to factor. I need to multiply across. I need to do all of that, right? But when I factor this one, remember, GCF is first. So some people like to do this stuff off to the side somewhere before they do the rest of the work here. That's why you have all this space. But if I were to do GCF, the GCF would be a 3x, leaving me with a 1 to begin with, a negative. The 3 is gone, but notice I still have an x. So I would have a 1 minus x in this problem. That's only this one. When I look at this top one right here, well, it doesn't have a GCF. Notice, by the way, I stopped after the GCF because there's no power of 2 anymore. I can't do anything to it. This one doesn't have a GCF, but I notice that we have a trinomial. So here's my negative 20, my positive 1. The only numbers that multiply to get it to become a 20, and then they subtract to give you a 1, would be a positive 5 and a negative 4. Remember, it's a positive 5 because I want to end up with a negative 1 after I combine. There's no number in front, so then this one just becomes x plus 5 and x minus 4. So notice right now I'm just going to take a moment and I'm going to factor all of them first. And then there's this one. Let's see, no GCF. It has 3 terms, so I'm going to go with the diamond method. We go with the negative 5. There's my positive 4. And the only way to multiply to get a 5 is a 5 and a 1. But because it's a positive 4, then we're going positive 5 and negative 1. And again, this is not a reducing diamond method or x factor, so we're going to go with x plus 5 times x minus 1. And this one needs no factoring because there's really nothing there. So now everything has been factored. So now we're going to rewrite this fraction. Now remember, when we're multiplying straight across. So notice, we're going to bring it down here. Now I'm just going to create one major fraction. This first one said 3x times 1 minus x. The red one, remember, I still need to write all of this. All of this goes on top. X plus 5 times x minus 4. See, that's everything on the top. Now I'm going to write everything that should be at the bottom. Well, the bottom is all this green stuff. X plus 5, x minus 1, and yeah, don't forget there's that little 3x that was just kind of floating there. I'll put it in parentheses just so that it doesn't look awkward, or we could put it in the front. So I'm going to start by looking at this and saying, all right, is there anything that can cancel out? Notice we're canceling because we have this single fraction going on now. And yes, look, x plus 5, perfect match. That should go away. We'll keep track of which ones we crossed out as well. And then look at this one, the 3x. 3x is a perfect match as well. Now, this one looks very close, right? Like it almost canceled itself out. But the x is negative, the 1 is negative in this one, so they're not exactly the same. But there is one thing I can do to this. So this is a very little special case here. For this one, see what I can actually do for that one. I can still factor one more time, but here's all I'm going to do. I'm going to take out a negative 1. Think of it that way. By taking out a negative, this x now becomes positive. This 1 now becomes a negative. And notice I switched the order 2 on purpose. And then everything else was still on top. X minus 4, and this was at the bottom, x minus 1. So as you can see, we can cancel this one out. It is exactly the same, but we had to take out a negative in order for us to do that. And so my answer is just negative x minus 4. Or if I distribute the negative back, negative x plus 4. So there's my answer. One of those two. Either of those two works. But remember, there were some values that needed to be excluded. So if this is on big ideas, remember they're going to say, hey, x cannot be. Notice how many times I'm going to write this. There are 3 values that ended up getting crossed out. See, the first one we did was x plus 5. So if it's x plus 5 cannot equal 0, subtract the 5, x cannot be the negative 5. So if you think about it, think of it as opposites. That was the first one I crossed out. And then we crossed out the 3x. Well, look, 3x cannot be 0. Divide by 3. X cannot be 0. Okay, there's my second one. And then this last one, remember, we kind of made one more little factoring to make it work. X minus 1 cannot be 0. Add a 1. So think of it as opposite. If you notice that connection already, these are the 3 values that are excluded. And this is what big idea is. So if you see them say x cannot equal, they're asking about the ones that got canceled out. Any questions or concerns on that? Feel free to ask me when we come back. So there you go. All right, now, if you go to the next page, there's 2 problems that you should try out. So take a moment to try those out, and then we'll continue the notes in a bit.